Right, now we are at the last section in this unit. It's called complex numbers, also known as imaginary numbers, okay? So not only do we have invisible things in algebra, we also have imaginary things in algebra. So remember earlier we talked about what if I had, let me do this. The square root of negative 36. Well, when my index is even, E-V-E-N, remember? 2, 4, 6, 8, 10, 64, whatever. If my index is even and I have a negative underneath the radical, then my answer is not a real number. And remember, if I had an odd index, okay, because again, if I multiply an even number of negatives, it always comes out positive. If I multiply an odd number of negatives, it can come out negative. So something like the cubed root of negative 27 would just be negative 3, okay? So from this point forward, not a real number is never an okay answer again, because we now are going to learn what to do with this. So what we do with something like this is, if we've got an even index and a negative underneath the radical, we're going to take this negative and pull it out, and we're going to call it an I for imaginary. So imaginary number, okay? So when that negative comes out, now I can just do what's the square root of 36, and that's 36i. The real part in the answer always comes first, the imaginary part second. Now here's the thing that you need to know big time. I squared equals negative 1. Because what we're trying to do is multiply an even number of negatives and get a negative number. So what we needed was this imaginary thing that said, if I square it, or to the 4th or 6th or whatever, I end up with a negative 1. So every time I say to you, I squared equals, you should say negative 1. Just so you know, once we start working with these imaginary numbers, and we really get into this, they are treated exactly like any other variable, an x, a y, a z, whatever, except for if it ends up being I squared. Then we automatically change it to negative 1. But other than that, it is treated exactly like any other variable. So let's just dive in and start doing some examples of things. So if I have the square root of negative 25, I have to take the negative out before I can, because I can't do the square root of negative number. So now I've got a positive 25. The square root of 25 is 5, and so my answer is 5i. If I have negative the square root of negative 81, well, I bring out the I. The negative stays there on the outside. The negative on the inside became the I. Then the square root of 81 is 9, and so my answer is negative 9i. If I have the square root of negative 7, I bring the I out. I can't do anything with the square root of 7, so my answer just stays that way. But the square root of negative 44, first I bring the I out, then I have the square root of 44. Well, let's do prime factorization. So everything else, guys, is exactly the same. So a 2 comes out, so I've got 2i times the square root of 11. Okay? Now let's start multiplying some things here. and all the other rules remain the same. So I'm going to take the I out of each of these, or the negative out, I guess I could say. Now, I'm going to multiply these together because I can do that since both radicals are squares. So I times I is I squared times the square root of 30. I need to see that's 2 times 15, 3 times 5. So there's nothing I can do with that, but I squared equals what? Exactly, -1. So my answer is negative the square root of 30. Let's do some more. Square root of -8 times the square root of -6. So again, I'm going to take the negative out of each of these, and then they become i's. And so now I get I squared times the square root of 48. 48, let's do my r prime factorization. 2 times 12, 2 times 6, 2 times 3, it's a square. So 2 times 2 is, so I get 4i squared times the square root of 3, but I squared equals -1. So 4 times -1 is -4, so my final answer here is -4 times the square root of 3. Okay, let's try some more. -5 times the square root of 7. So the square root of 7 doesn't have a negative in it, so no I comes out, so this is just I times the square root of 35. And I know that that is as reduced as it can get. Let's try some others. So I've got the square root of -80 over the square root of -5. All right. So I could do something like go I over 80 and I over 5. And first of all, these i's are gone because anything over itself equals 1. And remember, they're treated exactly like any other variable unless it becomes I squared. 2 times 10, 2 times 5. So I'm simplifying the square root of 80, and so I get 4 times the square root of 5 over the square root of 5. Anything over itself equals 1, and I get 4. How about, though, what if I did this? Well, first of all, negative divided by a negative is a positive, and 5 goes into 80 16 times, and what's the square root of 16? 4. You decide which way you like better. Okay, let's do another one. Square root of 40 over the square root of 10. So again, I could do this two ways, whichever one you like better. So this would be I times the square root of 40. Then I need to find, that's 2 times 20, 2 times 10, 2 times 5. So over the square root of 10. So that would be it would be 2i times the square root of, and 2 times 5 is 10, over the square root, what happened to this guy? Over the square root of 10, those are gone. My answer is 2i. But once again, I look at this and I say, let's do this. So I end up with -4, take out the I, square root of 4, 2i. Again, you decide which way you want to do it. Now, what about adding and subtracting? This is just like adding and subtracting polynomials, and we're looking for like terms. Okay, so the first thing I need to do is get rid of my parentheses. So the sign in front of this guy is positive, so when I distribute that positive to each of these inside, I can get rid of the parentheses. So a positive times a negative is a negative. A positive times a negative is a negative. Same thing again. I'm going to distribute this to both. Positive times a positive is a positive, and a positive times a negative is a negative. Okay, now remember, I always write the real part first, and then the imaginary part second. So since I need to do that, let's start with the two like terms that are real. Well, this is an addition problem whose signs are different, so I subtract the small number from the big number, keep the sign of the big number, so those are gone. Well, these are also like terms with my i's being the same. And so then I just look at the numbers. This is an addition problem whose signs are the same, so I add the numbers and keep the sign. There's my answer. Okay, let's look at one like this. So negative 1 plus 2i minus 4 plus i. Again, I just need to get rid of my parentheses. So positive times a negative is a negative, positive times a positive is a positive, negative times a positive is a negative, and negative times a positive, is a negative. Now I need the real parts, so that's an addition problem whose signs are the same. Add the numbers, keep the sign. So those are gone. And now these are like terms. So this is an addition problem whose signs are different. Subtract the small number from the big number, which is 1 and we don't write, and keep the sign of the big number. And there we go. So I'm just going to do a few of these. Let's try 8 minus 5i. Minus 12 minus 3i. So 8 minus 5i minus 12 plus 3i. This is negative 4. And this will be negative 2i. Done. Okay. How about negative 3 plus 2i plus 1 minus 3i plus negative 7 minus 5i. So again, just distribute the signs in front to get rid of the parentheses. So this is negative 3 plus 2i plus 1 minus 3i minus 7 minus 5i. So this, and this are my real numbers. So that's negative 10 minus 1 is negative 9. Done with these. Then these are my imaginary. So I got negative 8 minus 2 is negative 6i. There we go. I'm going to stop here. And no, actually, I think maybe I can get this last one in, and then we'll go to another video and keep doing examples. But I think I can get this one in. Just one more example to help you get this stuff down, hopefully. So negative 10 plus 6i. Negative times a negative is a positive. Negative 10i. These are my real. Oh, that's 0. And then these two, that makes it negative 4i. That's my final answer. So I'm going to stop here, and then I'll finish in the next video with more examples.